Hello, today I'm going to talk to you about composition functions. So our goal today is to learn about composition functions and be able to compose functions with tables, graphs, equations, and situations. Generally, when I think about composition functions, I just think there's a function inside another function. Let's see how our book defines it. So our book defines it as a composition of a function of f with g is denoted by this little open circle, f of g, and is defined by the equation f of g of x, which equals f of g of x, right? Just different notation. One lots of parentheses, the other with that little open circle. Where the domain of the composite function f of g is a set of all x such that x is the domain of g and g is the domain of f. So let me give you a little visual here. So think about g being this function here. And maybe a lot of times when we talk about functions, we say, oh, the function is a juicer. So I take a piece of apple, I throw it in this function, and out comes apple juice. Now you got to think, we're going to do something with that apple juice. So I take that apple juice and I put it into this new function f. Maybe this new function is a blender that we're going to throw some extra stuff in. And now it comes out as a smoothie. All right, so you've taken this apple, you turned it into juice, and now you've put it back into another function and you've turned it into a smoothie. All right, so that's just kind of the image of what's going on with a function inside of another function. All right, so we're going to start off with doing it by tables. So my first question is just a basic, can you find the value of b of negative 3? And all this is asking is saying, hey, my x is negative 3, what's y? Right? What's my y value if x is negative 3? So I go over here and I say, okay, well, if x is negative 3, right there, and I'm looking for my y value, in this case, the b function, using the b function, that answer is just 3. All right, let's step it up a little bit now and do a composition function. So if you have a of b of negative 3. So you always want to start on the inside. So you got to first figure out what b of negative 3 is. Well, we've done that already. We know b of negative 3 is 3. So we just take and replace b of negative 3 with its value, right, which we know is 3. And now our goal is just to go find a of 3. And so I just say, okay, well, now I want my x value to be 3, and now I want my a function. And so my answer to that question is just negative 1. All right, let's try another one. Now they've just thrown a different notation at us, but if you don't like that notation, you can just go back. I mean, you have to recognize its composition, but if you prefer to say, this is easier for me to write it like this first, so I know what I need to do first. I know I have to do this b of 0 first. So I say, okay, 0. So b of 0 is 2. So right away, I know I'm going to do a of, 2. I just want to try to keep my colors together. And a of 2 then is just going to be, go find your 2 value, and a of 2 is negative 2. So my answer is negative 2. All right, I'd like you to stop the video and try these two problems on your own. All right, let's check how you did. So I started here with a of 2, so I went to the x value being 2 and found a of 2 to be negative 2, so I replace a of 2 with negative 2. Then I find b of negative 2, so I go to negative 2 for the x, and I go over here to the b function. I find that answer is 9. And I got negative 4 for the bottom one. So I start with finding a of negative 3, so a of negative 3 is 1, and then a of 1 is negative 4. All right, so that's table. Next is graph. All right, so let's look at the first one here and see how we do with that. So v of 1, I'm going to start with v of 1. So I go to the x value on x is 1, and I see the y value right there is 0. So therefore, I know c of 0 is ultimately what I'm looking for. And so I go to the x value being 0, and I see what the y function is on the c. And you can see right up there, that answer is 5. All right, try these for me and see what you get. All right, so I got 3, 2, and 0. So you can see C of -3. So now I start with the x value, -3, and I go to 4, the C function. And so then I do V of 4, and you can see over here, V of 4 is 3. All right, then with the next one, I start with C of 4. So on the X, I go to 4, and I see the C value right there is 3, Y value. And so now I do V of 3, and you can see V of 3 is the Y value of 2. And lastly, I do V of 2 first. So I see V of 2 is 1, and then I do V of 1, which is 0. All right, now we've done tables, graphs. Next is equations. All right, so I'm going to start off with a constant, and basically what you have to realize is that you're just going to always start on the inside, and if you don't like it looking like that, then feel free to make it g of f of 1. And then you got to go calculate f of 1. And if you want to calculate f of 1, that just means you're going to take this function f, and everywhere you see an x, you're going to put a 1, right? So I'm going to write f of 1 equals 3 times 1 minus 4. And 3 times 1 minus 4 is -1. So I have calculated f of 1 to be -1. Okay, now I'm going to take that -1, whoops, and I'm going to replace all the x values over here with -1. So it's going to become -1 quantity squared minus 2 times -1 plus 6. And I simplify that. Remember, a negative squared is positive. 2 negatives make a positive. Plus 6. My grand total looks to be 9. All right, now let's do it a little more generic. Let's look at f of g of x. And again, if it helps you, just write it out like this. F of g of x. All right, so we're going to stick all of the g function in for the x value over in the f function. Okay, so how's that going to look? We've got the 3 and the -4. That's what's going on with the f function. And then I'm going to replace that x value with all of what g equals. So g is x squared minus 2x plus 6. All right, and once I've replaced this x value with all of this function, all that's left is simplifying. So I'm just going to go ahead and distribute my my 3 through. And I get 3x squared minus 6x plus 18, and then that -4 just carries down, and I combine like terms, and I get 3x squared minus 6x plus 14. That is my answer. Now I'd like to try it the other direction. If you think you got this, go ahead and stop the video and see what you get. Is it going to be the same as the one we just did, or is it going to be different? Well, let's check it out. All right, I'm going to start with taking the notation and just writing it a little bit friendlier so I know that f of x is my inside function. I'm going to stick all of the f of x in for every x in g. Okay, so I substitute 3x minus 4 in for those x's. Okay, so now I want to write that as 3x minus 4 quantity squared, and then minus 2 3x minus 4. And then the last thing that comes down is that plus 6. All right. And once I do that, now I just simplify it. So I square this, and please be careful that you realize that you cannot distribute powers, right? We can't just take that 2 to the 3x and call it 9x squared and plus 16. You have to make sure you're foiling, so you have to do inside, outsides, boxes, multiply these together. So that's going to be 12x and another 12x. That should be minus 12x. Let me fix that real quick, sorry. Talking and writing at the same time doesn't always work for me. So yeah, the inside's gonna be minus 12x, and then another minus 12x, and then a plus 16. Then I'll distribute these guys through. I'm gonna run out of space here, so I'm gonna line them up. So that's gonna be minus 6x, and then plus 8, and then the plus 6 at the end. Okay, and so now you can see from here, I can now simplify this and see I have 9x squared minus 20x plus, whoops, I meant 30x, I meant 30x plus 40. All right, that is how we do it in equations. And then one thing that we do in calculus that is kind of fun is trying to figure out which function's inside the other function. And this is important for later things we will learn. But let's go back to what we started with and talk about the domain. So the domain of H. All right, what do you think about this? Now, I don't know what that looks like graphically. You probably don't know what that looks like graphically without using your calculator. So when I think about domain, I think about what can X be? So in this case, I know I can never divide by 0. So X cannot be -3, right? Because that creates division by 0. So X is everything but -3. All right. So now I would like you to think of H being a composition function, f of g of x. Can you find what you think f is and what you think g is? All right, this is not unique. Your partner or the person next to you might not find the same thing. All right, so take a minute, think about it, see what you come up with. All right, this was my first thinking. I know the inside function could be x plus 3 cubed. So I called that my inside function. And then my outside function would be 24 over x, because if I replace the x with g of x, I will literally have 24 over x plus 3 cubed, right? I'm replacing this x with g of x. Somebody else might have said, oh, my inner function is just that line, 3x plus 3. And then my outside function would be 24 over x cubed. Remember, you're going to replace the x and f with g of x, and that gives you the same thing too. Let's try one more. Talk about the domain, so think about what x can't be. And again, it's the same situation. We can't divide by 0, so it's -infinity to -2. And then again, from -2 off to infinity. All right, now think about what are some options for your inside and outside function. So what is f? What is g? What are some different possibilities? See if you can't come up with a couple this time. All right, here's the couple I just came up with. So I said my inside function was all of this stuff, 1 over x plus 2, and then my outside function would be x squared minus 5. Again, if you're composing, you're replacing all of these x's with g of x. And if this is all g of x, you can see it goes in right there. I also said, well, if I let my inside function be all of that stuff, then my outside function could just be x minus 5. And you can see that works as well. So some couple options for you. All right, now let's go shopping. All right, let's see how compositions work in the shopping world. So the first thing is this computer store, they're having a sale. And they're giving a couple options. They give $300 off coupons as well as 15% off discount. So let's just write those two equations out. So a $300 off coupon is just going to be whatever my price was minus $300, right? That's what the equation for the coupon is going to be. Now, if I get 15% off, the value of my thing isn't going to be 15 off. You don't want to think about that as much as more as how much are you still paying. So I'm still paying 85% of the price. Okay, so my discount equation would be 0.85x. All right, and so now we want to calculate those values when the price of the product is $1,400. So the first one's pretty easy. You take your $1,400, you subtract $300. Okay, so you're going to end up paying $1,100 for that computer. Okay. Now the next one's not too bad either. I'm just going to grab out my calculator here. I'm going to take $1,400 and I'm going to multiply it by 0.85 and I get $1,190. So this one gives me $1,190. So if I think about this, if my computer costs $1,400, right, and I took the $300 off, I'd end up only paying $1,100. Better option, right? If I took the $1,400 here and I took the 15% off, I would end up paying $1,190. So it's actually going to be a little bit more expensive to use the 15% off coupon rather than the $300 coupon. So you can see you want to do the coupon in this method, helping to make you a smarter shopper. All right, but here's the cool thing. Sometimes they let you use both. And they never give you the better one, FYI. But I want to figure out which one would be better so I could try to convince the salesperson to do it this way. All right, so I got to go find my D of 1,400, which I found on the last one, right? So D of 1,400 was 1,190. And now if I take that 1,190 and I subtract, right, because I put that 1,190 right in here. So 1,190 minus the 300. Now you can see that price is going to be $890. So I'm going to pay $890 for that computer if they allow me to take the 15% discount first and then subtract the $300. Now let's switch the order around and do the other way. Let's say they say, well, how about you take the cost off, the coupon off first, so that we already found that C of 1,400. So now we know that's 1,100. So now I'm going to do D of 1,100, which means I'm going 0.85 times 1,100. Okay, and if I throw that in my calculator, what do I get? So 0.85 times 1,100. And I get $935. Okay, and if we think about that, we could have probably guessed which one would be better, right? Because when you're thinking about the discount, if you take the discount off first, then you've taken more money away from the total price than if you remove the $300, because that 15% would have been of the 300 too, and so then that would have reduced your cost. So that's why it'd be great if they let you do the discount off the whole price and then just subtract the $300. But they usually don't do that. But either way, you know, you're getting a pretty good deal. So here you are going to write this as a general equation. So we want to come up with this equation for them. So instead of writing C of D of 14, let's put these in. So I want to do C of, which is the better rule? So C of D of X. That is the better rule. Oh, for the department. Sorry, I'm thinking business-wise. All right, so we have to do the other direction. So the better thing for the department store, because that's really how it'll be done, is to take the coupon off first and then do the discount. So they're really looking for D of C of X. So that means I'm going to take all of C and stick it in for this X on the D function. So therefore, I'm going to do 0.85 times, x minus 300. Okay, and you could go ahead and distribute that through if you want to make it look a little nicer. And if I do 300 times 0.85, I get 255. And now you have a direct way. So if you go and buy some other computer for your friend or maybe some other electronic device, you don't have to keep doing it this way. You can now just put it in for X and you'll get the price. All right, so that is composition in a nutshell. I'd like you to take some time to work on your homework.